Hey everybody. All right, another type of test is the ratio test. And it looks a lot scarier than it is. Just stick with it and we'll figure it out together. Um, this is the one if I had to predict that they'd probably give you on the national exam, but we'll get to that when we start reviewing some more problems. So here's how it works. It says the limit as n approaches infinity of the ratio of consecutive terms. And so the notation here, it says n plus 1 over n. That's talking about terms. You're going to set that ratio equal to some limit. We'll call that limit L. Once you have that limit evaluated, if L is less than 1, then the conclusion is it's convergent. If L is greater than 1, then we conclude that it's divergent. And if L happens to equal 1, then we're going to be grumpy because it's inconclusive and we have to do something else. Let's see it in action, then we'll go back and talk about the notation here because, again, it's scary at first. All right, example. Let's find, we want to know the series n factorial over 2 to the n, does the following converge or diverge? So you could go through your list of stuff we talked about, why this is not a p-series, because the exponent's an n and not a number. It's not a geometric series because there's a factorial in it. There's no -1, so it's not an alternating series. And so we kind of run out of options rather quick. One other thing about the ratio test is if you see a factorial in it, you will be using the ratio test. So that's kind of your go-to. You can skip all the other ones. So here's how it works. We're going to first set up a limit as n approaches infinity of the ratio. And the top here is supposed to be the n plus 1th term. So what does that mean? Well, it means wherever there's an n, I'm going to put in an n plus 1. And on the bottom, it's just a to the nth, and that's just the nth term. And that's just because that's always going to be just the actual notation for the series. And so we want to figure out what this limit equals. And again, if you plug in infinity right now, we never done infinity factorial, whatever that means. But the idea is you're always going to be able to simplify this using algebra. And it's the notation, again, is the scariest. So I'm going to show it in all of its glory here. And again, you can pause it, slow it down, watch it again, because it'll be that good. But one thing I like to do always is I keep the numerator where it's at. And then I multiply by the reciprocal. Because remember, when you divide by a fraction, complex fraction, we can move that denominator up, factorial down. And what's always going to happen with factorials, and especially exponents, if those happen to show up, is there's going to be some things that cancel. And so I'm going to start grouping together some of these terms. One thing we can group together are these terms. And so if I do a little side over here, come on. One thing I usually ask students is, dude, stop, is, how many 2's are on the top and how many 2's are on the bottom. And the idea is there's always going to be one more 2 on the bottom. I hope you don't have to write this every time, but you can think of this as 2 times 2 to the n. Remember those exponent rules? You can add the exponents. 1 plus n would be n plus 1. So if you simplify this, long story short, this thing right here simplifies to 1/2. And so this is really going to end up being the limit as n approaches infinity of 1/2. And then what we have left over is n plus 1 factorial on the top and n factorial. So then in my little sidebar over here, I would ask students, okay, what has more terms, the top or the bottom? And we haven't done factorials too much in this class. You should have seen them hopefully in the past. But the factorial works as, n plus 1, and then you take away 1 from it. If you take away 1 from n plus 1, it would be n. Then you take away 1 from n, and it'd be n minus 1, n minus 2, and so on. But you could also write n plus 1 factorial as n plus 1 times n factorial, especially since you don't know what n is, and n could go on forever. N plus 1 times n minus 1 times n minus 2 times n minus 3. So this little handy definition allows us to rewrite this as the limit as n approaches infinity of 1/2, and then on the top we have n plus 1 times n factorial over n factorial. Those cancel, and now we have the limit as n approaches infinity of 1/2 n plus 1. So how does this play out? Well, if you actually take the limit now of this essential line, 1/2 n plus 1, or you substitute infinity, or substitute the idea n of infinity, the limit equals infinity. But infinity is greater than 1. I'm going back up to my definition up here. So the conclusion after all that algebra is that it diverges. So the conclusion's kind of nice, but sometimes it takes a little bit getting there. All right, let's do another example if you're not quite sure about that. So again, same type of thing. We've got a factorial in it. Does the following converge or diverge? We're going to jump right into the ratio test. So first we're going to set up our L. So we want to find the limit as n approaches infinity of n plus 1 squared over 2n plus 1 minus 1 factorial, kind of gnarly, and then over the nth term, which is just going to be everything stays the same. So again, this looks like a headache, but we're going to trust ourselves. And again, we want to really figure out, is this expression going to be less than 1 or greater than 1? So I'm going to rewrite it. Again, it's bad form if you don't write the limit every step. If you don't write it, you're implying that you've taken the limit. We're not going to do that till the very end. So, all right, I'm going to simplify this a little bit. So it's going to be 2n plus 2. So I'm going to have a 2n plus 2 minus 1. So 2 minus 1 is 1. And then I'm going to keep, I'm going to multiply by the reciprocal. So I'm going to have a 2n minus 1 over n squared. All right, so now we're getting somewhere. So I'm going to try to combine some of this stuff, particularly the factorials. So if I look at 2n minus 1 factorial, first thing I would think or ask you is what has more terms, the bottom or the top? Pause it, think about it, do what you need to do. The answer is going to be that the bottom has more terms. And so I'm actually going to leave the top alone. And if I take away 1 from this, it would be 2n plus 1. Take away 1, it'd be 2n. Take away another 1, and it'd be 2n minus 1. And whichever one we end up with, we don't want to do 2n minus 2, 2n minus 3, so I can throw a factorial on that. And so that denominator is equivalent to 2n plus 1 times 2n minus 1 factorial. Why did I stop there? Well, I don't want to go on forever, but I also kind of want to stop when I can get rid of the numerator. And so if you notice, I'm going to be able to cross those factorials out and get rid of that and essentially rewrite it as 2n plus 1 times 2n. That's what the factorials are going to simplify to. So if I rewrite this, I'm a little worried about space here, but we'll have faith. I've got n plus 1 squared. I crossed out this. On the bottom, I've still got 2n plus 1 times 2n. And then I've got this thing left over. So it seems like it's still a big mess, but this is where, and I said this at the beginning of this semester, it's not a lot more work. It's just it's the abstract notation of it, and this is a limit that we can actually evaluate pretty quickly. And so it's going to happen quick. So here we go. All I really care about is the degree on the top. You know, we have n plus 1 squared. I could FOIL it out. I could make a trinomial of that stuff, but the leading degree is going to be n squared plus some other junk. You know, 2n plus 1 if you want to get crazy. The bottom would be a waste of time to multiply out. You could do it, but if you did it, the leading term would be 2n times 2n times n squared. Specifically, n times n squared. So I'd really have a 4n, because those 2's, 4n squared plus some other junk. And the reason that's the only thing that's important is because when you take limits, especially as n approaches infinity, all you really care about is that leading coefficient. And that limit is going to be, oh, I almost said 1/4, but it's n times n squared. That should be a 4th power. Oh, I would have to edit the video. So that limit I was going to say is 1/4, and it would be if these were the same, but it's a 4. So yeah, the limit's 0, because the bottom degree is larger. And if the limit is 0, 0 is less than 1. And our definition says that if L is less than 1, it converges. Good stuff. Hey, it's tricky, but it's okay. We'll get through it together. It takes a little practice. But those are a couple examples of the ratio test. Thank you for watching.